Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you. I am Raghunandan Sengupta from IME department IIT Kanpur, and this is the DADM lecture 1, that means the DADM 1 lecture number 8, and as you know this is a course for 12 weeks which is 30 hours, and we have just started discussing about the different type of distributions, discrete case distributions, and we will give simple examples as well as solve them and give small examples for an exercise which is, as I told, are not part and parcel of the assignments, but they would be more to inculcate the interest in all the people who are taking this course. So, if you remember, we considered the binomial distribution just the last slide for the 7th lecture. So, binomial distribution is basically, as I told you, is an expansion coming from the concept of binomial expansion. Now, binomial distribution is in some way relate, obviously for all the distributions when we are saying it is the Binomial trial. So, in the binomial distribution there are two outcomes, head, tail, good, bad, red, yellow, yes, no, whatever it is, and the distribution is given by the binomial distribution which is NCX p to the power x q to the power n minus x. Now, remember that what I told repeatedly in the last class is that p is the probability of a success or a failure, whichever you look at. Q is the probability of the failure or the success, because if p is success then q would be the failure, and if p is the failure q would be the success, or p can be the number of yes, q can be number of no's, p can be number of no's, q can be number of yes, whatever it is, they are complementary to each other. X would be the total number which is coming out as true or false or red or white or black or white, whatever it is, depending on what the value of p is. So, if p is yes, then x would be the number of yeses. If p is basically white, then x would be for the number of whites, and n is the total number of throws which you are going to do. And you remember that I did mention that I will only give the formulas for the expected value, but technically the derivation on these things are very easy, they can be derived accordingly. So, in the case when you have the distribution as say for example binomial, the expected value is n into p and the variance is n p q, and the corresponding the way how you denote is that x is binomial which is b with parameters n and p. So, if you draw it, I am using very simple Excel sheet. The binomial distribution would look like this. So, you have basically 50 as n, and n would basically be depending on where you are basically consider. So, if you are considering the expansion, let me write it. So, it was NCX p to the power x q to the power n minus x, and x can take values of 0, 1 till n. So, the first term is NC 0, p to the power 0, q to the power n minus 0. Then next term would be basically when you go to the next term, this is x is 0. When you have x as 1, you will have NC 1, p to the power 1, q to the power n minus 1, and it goes to the last term which is NC n, p to the power n, q to the power n minus n, x. So, this value would basically coming here, this value would basically here, and so these would be the corresponding values you are going to plot. Now, remember, if you increase p, correspondingly q would decrease, or decrease p, q would increase. So, in that case the distribution which you see here would basically shift here or here depending on the value. So, it will just a shift. So, how you plot it would basically depend on the values, keeping n as fixed. it will depend on the value of P and Q. So, P is very small, Q would be very large, that means large means almost equal to 1, P would be almost equal to 0, or P is 0.5, Q is 0.5, or P is very large almost equal to 1, Q would be almost equal to 0, you can basically get the values accordingly. It is very easy if you draw it and basically understand it accordingly. Now, consider a very simple example. 20% of the BSNL shares are owned by Mr. Murali Lal. A random sample of 5 shares is chosen. So, I want to find out, or we want to find out, what is the probability that at most 2 of them will be found to be owned by Mr. Murali Lal. So, if 5 are chosen, so n would be 5. So, as we are discussing the binomial distribution, let us also discuss a very simple example for this. So, the problem states that 20% of the BSNL shares are owned by Mr. Murali Lal. A random sample of 5 shares is chosen. So, which means n is 5. So, what is the probability that at most 2 of them would be found to be owned by Mr. Murali Lal. So, at most 2 means the value of x. Now, what is x? We are going to define that. The value of x can be 0, can be 1, can be 2. In other sense, if you are looking from the other side, at most 2 would be, the complement would be 3, 4, 5. So, how you place that problem and what you consider P and Q would be important. In one case, if you take P as 20, Q would be 0.8. In another case, P can be 0.8 and Q can be 0.2. So, we will state the problem, you will understand, and then I will explain. Consider here a P as 0.2. So, that means 20% of them are owned, 80% are not owned. So, Q would be 0.8. Hence, the required probability would be in the case at most 2. So, you will find out x values being 0, 1, 2. So, when it is x is 0, the corresponding probability would be n. I am writing on the formula and then going to say that what are the values corresponding to n, p, x, and so on and so forth. So, we know n is 5. So, this is 5. I will also use a different color to highlight it. So, this is 5, which is n. So, this is n. Okay, now we will consider. Okay, then I use a different highlighter red. So, x value would be corresponding to the case when x is 0, x is 1, x is 2. So, x is 0, x is 1, x is 2. So, now we need to and these values are also 0, 1, 2. Now, I want to find out and highlight, not find out, highlight that value of p. P we have considered as 0.2. So, P would be 0.2 here, 0.2 here, 0.2 here. We have considered Q. So, Q is 0.8 here, 0.8 here, 0.8 here, and the values which you have, I use let me use a magenta color. So, the value which you see here, technically the this one 5 here, 4 here, 3 here, that is basically n minus x. So, in the first case it will be 5 minus 0. Okay, I should be using. So, it is 5 minus 0 for the first case, which is here, 5 minus 1 which is 4, which is here, 5 minus 2 which is 3 is here, and the corresponding values of x's are changing. So, these values which I am writing 0, 1, 2 are basically the x's depending on which reading you are taking. Now, as I mentioned just in the last slide, that if you take the complementary part, that means you take the formula this as 0.8 as p and 0.2 as q. In that case, I will write the formula in the same way, there is no change. So, p becomes 0.8, q becomes 0.2, but here the x what I am denoting here, let me highlight using light blue. Okay, let me use orange. The x which I am using here, that would give me the probability of the complementary part corresponding to the case when you are considering x as the number of shares which you are holding. So, in that case it would be the number of shares we are not holding. So, in that case when you want to find out x is maximum value of 2, in the other case it would be the values complementary would be 3, 4 and 5 corresponding to the says the overall universal set is 5. So, Mr. Abhishek Bhatia finds that 70% of the students have answered question number 1. This is an assignment which you can solve when you understand the concept, but they would be always not an part and parcel of the assignments which you are going to solve each and every week. Mr. Abhishek Bhatia finds that 70% of the students have answered question number 1 correctly in his chemistry exam. So, obviously, if you consider P as 0.7, Q would be 0.3. A random sample of 10 answer scripts. So, N is 10 is chosen. So, we want to find out what is the probability that at least 3 of the students have answered question number correctly. So, at least 3 would be 3, 4, 5, 6, 7, 8, 9, 10. If that is the case, then you will consider P who have answered the question as 0.7, Q as 0.3. Now, if you reverse it in the sense you want to find out those who have not answered. So, on obviously in that case if it is at least 3. So, obviously it will the complementing part would be 0, 1, 2. In that case P would be 0.3, Q would be 0.7 and you would solve the problems accordingly. Now, consider the next distribution for the discrete case or the probability mass function for the negative binomial distribution. Negative binomial distribution here again x is the random variable, n b is the negative binomial, the short form for that, p and r are basically the parameters which are corresponding to that distribution. So, f of x is given by, now this is not complicated, but it is very straightforward if you understand it. So, the distribution will be r plus x minus 1, c r minus 1, p to the power r, q to the power x. And p value, so mark it here, the suffix for p is r which is a fixed value while q is x, and x values are r plus 1, r per 2 till infinity. So, p and r are the parameters, p is obviously between 0 and 1, correspondingly q would also be between 0 and 1 because p plus q is 1 and the r values would be integer values like 1, 2, 3, 4, it can be 0 also 1, 2, 3, 4, 5, 6 till infinity. Expected value is given by r q by p. I will like you to note down this formula r q by p and why I will come to that later. Variance is given by r q by p square. And an example, consider the example above where you are still inspecting items from production line, but now you are interested in finding the probability distribution of the numbers of failures preceding the 5th success of getting the right product. Then we have corresponding to p is equal to 0.8, q is equal to 0.2, the actual distribution would be given by, so 5th success. So, here r is 5, so it will be r plus x which is 5 plus x minus 1, c 5 minus 1 which is r minus 1, p is 0.8, 0.8 to the power r which is 5, r is 5. So, 0.8 to the power 5 and q which is basically 0.2 to the power x. Now, listen to the actual framework or the background of the problem. Consider that you want to basically find out the distribution till you get the third head or third bad items or third good items, whatever it is. 3 is basically what we consider an R. So, it can change also. Now, consider the problem like this. The first two and consider that x is basically the number of such trials you are going to do. Now, consider this, if the third one comes as head, you stop the experiment. So, fix the third one. Before that, on to the left you would have what are the actual combinations you can have. So, obviously, there are 2 heads already in some place on to the left of the third one, that means you are starting from the left side. Now consider there are x plus 2 number of seats or places to be filled up. So, 2 corresponding to the initial first and the second head, and x places are corresponding to the tails. Now, if I ask you the question that if there are x plus 3 minus 1, with this 2 x plus 2 number of seats, and you want to fill up with them with either x places being tail and the 2 other places being head. So, the total number of combinations would be very simply r plus 2 c 2 or r plus 2 c r minus 1 in this case, because you are considering the x minus 1, that is why we are considering. So, these places would be filled up. So, consider the first is tail, next is head, next is tail, 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 then head, then tail, and the last one is basically head, the third head. So, obviously, you close the experiment. So, the total number of combinations which you can have before the third head comes is basically given r place r minus 1, which is the heads, x are the tails, they can be combined in the values of r plus x minus 1 c r minus 1 or r plus x minus 1 c x. So, whichever you do, the combinations will come out to be true. Now, if that is done, now the next question is what are the probabilities. So, the probabilities of picking up the tail is q, because we are considering that in unbiased coin obviously it will be half and half, the probability of picking up the tail is q. So, how many such places has tail been picked up? So, they are x in numbers. So, the corresponding probability would be q into q into q such x number of times, hence it is q to the power x. Now, the next question is that how many number of p's are there, that means heads. Remember that the third one has already been picked, that is why he ended the experiment. So, technically we had r minus 1 heads. So, this is p to the power r minus 1 already picked up. The last place is also p, which is head. So, the total number of such combinations of the heads would be p to the power r minus 1 into p, that means it is p to the power r. So, the total probability would be, the total combinations would be r plus x minus 1 c r minus 1 p to the power r q to the power x, or else it can be r plus x minus 1 c x p to the power r q to the power x. So, whichever you look at the problem, answer is same. So, let us consider a problem accordingly. So, we will before that, as usual, this is the diagram. So, the negative binomial distribution, depending on what the value of p is, what the value of q is, you could basically have the distribution like this. Sorry, I am using a highlighter, I should change it. So, if you change the value of p and q, it can go like this and so on and so on. So, you can draw it and understand it accordingly. Just take, here I have taken 30, just take 20, plot them, consider p value as 0.5, q value as 0.5 and fix r take as 3, and then you keep changing the values in p and q such that the sum is always 1 and you can get the nice distribution of that. Now, suppose that the probability of a manufacturing process producing a defective item is 0.05, and also suppose further that the quality of any one atom is independent of the quality of the other atom which is produced. So, they are independent, that means you are going to the concept of Binomial trials. If Mr. Rao is the quality control officer who selects items at random from the production line and he stops inspection when he gets 10 good items. So, that means the 10th one he gets good, he stops it. Then what is the probability of getting 2 defective items before he stops, which means that he has to have 9 good items and consider the case. So, these 2 are the defective items. So, the total combinations we can fill up the places before the 10th one is picked up is good is there are 9 items which are good, 2 items which are bad, they have to be picked up accordingly. The defective items probabilities are 0.05. So, 2 items being bad is 0.05 square and 9 atoms being good, it will be 9 to the power 1 minus 0.05, which is 0.95. So, with this background I will basically come to the actual values to illustrate. Here P is 0.95, which is good, Q is basically bad, which is 0.05. Hence, the required probability would be for the case there are 2 bad, 9 good beforehand. So, obviously, the formula would be, so if you remember, it is R plus x minus 1. So, R is what? You have basically picked up R as 10. So, 10, because you will stop it when you get the 10th item is good. So, 10 plus 2 minus 1 C x or C r minus 1. So, R is basically 10. So, it becomes 10 minus 1 or x is basically here given as 2. P to the power r, Q to the power x, P is 0.95 to the power r is 10, Q is basically 0.05 to the power x, which is to solve that and get the value. So, and this is just a simple assignment, which I will just discuss as I am discussing that for the other distributions also. Mr. Agarwal is the immigration official of Indira Gandhi International Airport, and he knows that the probability of an Indian origin person coming in any flight from abroad is 10%. So, obviously, coming 10%, foreigners being complementary of that, which is 0.9. He notes down the country of origin of the person and stops when he knows he has noted down exactly 3 people of Indian origin. Then what is the probability of Mr. Agarwal noting down 2 non-Indian origins before he stops his checking? So, if we exactly 3 of Indian origin, which means 2 Indian and 2 non-Indian, because 2 plus 2 has already completed his 4, then the 5th one he gets an Indian, he stops. So, these 2 and 2 combinations can be done in the way, that means 2 places as Indian, 2 places as non-Indians, and you basically find out the corresponding combinations. The values of P and Q are given. Indian origin coming is 0.1, in non-Indian origin people coming is 0.9. Here the value of x, which is non-Indian, is 2. Here also Indian is 2 plus 1, because there is the third one, when he comes he meets the Indian one, he stops. So, I put those values and solve it accordingly. Now, we will consider the geometric distribution. So, if you have understood the last distribution, negative binomial, geometric distribution is just simply an extension of that. And if you remember, I told you, please note down the expected value and the variance for the negative binomial, which were basically r q by p and r q by p square. So, Q and P can be interchanged depending on how you have been basically trying to denote P and Q, good, bad, red, yellow, whatever it is. Now, this distribution, which is random variable x, is given by the geometric distribution G and the parameter is P. The underlying fact is here R is 1. That means, the moment you get the first bad item or a first good item, whichever you are looking at, you stop. P is the parameter, values are 0 and 1, Q is the parameter values which is complementary 0 and 1. Expected value is given. If you put R as 1, so it becomes Q by P, variance again R as 1, variance becomes Q by P square. So, consider the example below, but now you are interested in finding the probability distribution on the number of failures preceding the first success of getting the right product. Then we will have basically P as 0.8, Q as 0.2. Put them in the equation, which is, because R is 1. So, obviously, P to the power R, where is 1, it all will be fixed, that is, it will be P, and you want to find out the number of such bad items. That means, all of them are bad before you pick up the good item, and obviously, if the places x are all being filled up by bad. So, now obviously, the number of combinations would be 1, because this is you are picking up n from the n, or you are technically you are picking up x from the x, because R is 1. So, in that case the formula becomes the initial variable in front of P would basically be 1. The geometric distribution would exactly look like the negative binomial, but obviously, as the parameter of P and Q again will change, but here remember the R value is 1 and you will basically have the distribution. So, it can be like this, depending on how you have been trying to pick up the values of P and Q. So, P is very large, Q is very small. Large means almost tending to 1, Q being almost tending to 0, or Q being very large when it is equal to 1, Q being and P being basically very small tending to 0. So, you can basically do it accordingly. So, geometric distribution problem. A recent study indicates that Colgate toothpaste has a market share of 45% versus 55% of Pepsodent. Ms. Dabbawala, the marketing research executive firm, wants to conduct a new taste test for which she wants users of Colgate. Potential participants for the test are selected by random screening of users of toothpaste to find out Colgate users. What is the probability that 5 users will have to be interviewed by Ms. Dabbawala to find out the first Colgate toothpaste users? So, here 55% are Pepsodent, 45% are Colgate, and she wants to find out the probability that 5 users will have to be interviewed by Ms. Dabbawala to find out the first Colgate paste users. So, all the other 5, remember here, listen to the words very carefully. If 5 users have to be tested, which means the 5th one is Colgate, other 4 have to be the other way down. So, x would be marked accordingly. So, here p is 0.45, q is 0.55, and the probability would be x is 4, because 4 of them are non-Colgate. So, here it will be obviously the variable in front of p, that means what you have been using for negative binomial distribution as r plus x minus 1 c r minus 1 or r plus x minus 1 c x would obviously be 1. So, you will have 0.45, 0.45 to the power 1, and the value of for the Colgate and or the Pepsodent, the variables are such that it will be 0.55 to the power 4 depending on as x as 4. So, if it was in the example, it was given that you have to pick up 5 non-Colgate, in that case it will be 0.55 to the power 5. Assignment for the geometric distribution. So, the question is like this: Mr. Moti Singh is a lottery ticket salesperson and he knows that the probability of a person coming to him whether he or she has won the lottery is 1%. What is the probability that 10 persons arrive before the winner arrives? So, in this case, consider whether he or she has won the lottery is 1% is 0.01, non-winning is 0.99, and what is the probability that the 10 persons arrive before the winner arrives. So, that means 10% have already arrived who have not won, 11th one is basically a person who has won. So, the total corresponding probability would be, so if it is not winning and if the probability is 0.99 to the power 10, and p is basically for winning is 0.01 to the power 1, because obviously that is as we have considered as r as 1, you put the values and solve it accordingly. So, with this I will close this 8th lecture and continue the discussions further on for the other discrete distribution and then come slowly into the continuous distribution. Have a nice day and thank you very much.